In today's video, we're going to discuss the third of the old trade models. This one is called the Heckscher. Olin model. Heckscher-Olin model. Now, this model is going to be different in setup from the other two, in that, once again, we'll have two countries and two goods, but now we're going to have two factors of production. If you recall, the Ricardian model, we had one factor of production, labor, which was freely mobile across the two sectors. In the specific factors model, the second one that we covered, we had three factors of production, two of which were fixed or specific to one each of a sector, and the third one, which was mobile. And as discussed in that video, we consider that specific factors model a short-run model because of the fact that the factors aren't all freely mobile across sectors. Well, here in the Heckscher-Olin model, we go back to now down to two factors, and we'll work with capital and labor. K for capital, just as before, and L for labor. And both of these factors will be freely mobile, right? They can move between our two sectors. And just for the sake of this example, we're going to work with S is going to be for shoes, and C will represent computers. Now, some important additional assumptions, aside from the very important assumption that our two factors are free to move between the two sectors, right? No cost of moving from one sector to the other. And once again, we continue to assume that those factors are homogeneous. Okay? We're maintaining all those assumptions. In addition to those, we're going to make some other very, very important assumptions. Now, the first assumption, or the first really two assumptions that we're going to have, those are meant just to set up this specific example for us. So we're going to assume that computer production is capital intensive. Okay? And so this notion of factor intensity, this is at the core of understanding the Heckscher-Olin model. Okay? So what do we mean by computer production being factor intensive? Well, what we're saying is that the ratio of capital to labor that is employed in computer production is higher than the capital to labor ratio in shoe production. Okay. Now, of course, if we're saying that computer production is capital intensive relative to shoe production, and that's a key thing, this is a relative concept, right? Comparing the ratio of capital to labor employed in computers to that same ratio for shoes. So if we're saying that computer production is capital intensive, we're also saying that shoe production is labor intensive. Right? Or in other words, the labor to capital ratio employed in computers is lower than that for shoes. Okay. If one of these is true, then the other is true. Okay. So that's one key assumption we're making for the setup of this model. We're saying that the production in computers is capital intensive. Now, graphically, we can illustrate that with the following. And we're going to make use of this graph a little later on when we're showing what happens to the wage to rental rate ratio. Okay. So if we have down here our labor to capital ratio that's employed, and our y-axis will be the wage to rental rate. Okay. So R is the rental rate for capital, W is the wage for labor. So if we're saying that shoes are capital intensive, flip side of that being that, that computers are capital intensive, so shoes are labor intensive, what does that mean? Well, that means that for any given wage to rental rate, the ratio of labor to capital employed in shoes is higher than that for computers. Okay. This is important to keep in mind when we have this assumption, when we're saying that the ratio of labor to capital employed in shoes is higher than that for computers, we're saying that's at the same wage and rental rate, right? So the firms are facing the same input prices, okay, for our comparison point. And you can see that if you take any wage to rental rate, say like W over R0, if you take this one, very clear to see that the ratio of labor to capital employed in the shoe sector is higher than it is in the computer sector. Okay, so this is our basic concept of factor intensity. And as I said, keep this graph in mind. We're going to use this again later on. Okay, so introduce it here, and then you get a chance to see it again. Hopefully through that repetition, it'll start to sink in. We can set this one aside for now. We're going to continue with our assumptions, and then we're going to show our two PPFs. Okay? One for the home country, one for the foreign country. So one key assumption here is for the setup of this particular example, we're assuming that computers are capital intensive, therefore shoe production is labor intensive. The other assumption we're going to make here is that the home country is capital abundant. Okay? And like factor intensity, factor abundance is itself a relative concept. Here what we're doing is we are comparing the capital to labor ratio on the supply side. Right? So for the home country, if we're saying that the home country is capital abundant, it has a higher relative supply of capital compared to the foreign country. Okay. So that's our first or second key assumption in terms of the setup specific to this model. Okay. So we could, these two assumptions, if we're doing a different model, we can change those assumptions around, make the shoe sector capital intensive if we wanted to. Okay. So the general insights from the model don't hinge on which sector we make capital intensive or which country we make capital abundant. We just need to make some assumptions in order to work through the example. However, we're going to make a couple other simplifying assumptions just to make it easier to work through this model. The one key assumption we have here is that technologies are the same across the two countries. Home and foreign shoe producers use the same technologies. Home and foreign computer producers use the same technologies. Why is that assumption important? Well, this helps to rule out reversals of factor intensity. In other words, if computer production is capital intensive in the home country, it is also capital intensive in the foreign country. Without that, things can get a lot more complicated pretty quickly. I encourage you to take a really good look at the example of the New Balance factory that's in our textbook, which is an example of actually a reversal of factor intensity in the real world. And we'll discuss that a bit more in class. But for now, we're just going to set aside the possibility of reversals of factor intensity. Second key assumption to help simplify things is that consumer tastes or preferences are identical across the two countries. Okay? And that helps to keep things, again, it's just a simplifying assumption, helps it make it a lot easier working through the model. And as I said before, it's also important for another reason. Right? We're trying to focus in each of these models, we're trying to focus on how one thing, right, one difference between the countries can lead to the basis for trade and predict the patterns of trade. Right? So in this case, in this model, we're focusing on the difference in factor endowments. Right? We're going to focus on the fact that, according to our setup, the home country is capital abundant, and how that will predict the pattern of trade along with the assumption of which industry is capital intensive. If we were to add into that very drastically different preferences by consumers in the two countries, we wouldn't be able to back out whether the pattern of trade is being determined by the factor abundance, the relative factor abundance of home versus foreign, or the difference in preferences. So by keeping preferences the same across the two countries, we can isolate and focus on this key difference between the two countries. So if we take all of this information that we have, right, our assumptions of the fact that computer production is capital intensive and that the home country is capital abundant, what would that mean for our PPFs, and what would that mean ultimately for our relative price of computers in the home versus the foreign country in autarky? Remember, autarky means without trade. So to be consistent with the way we're setting things up and the way your textbook looks at things, I'm going to put the computer industry on the x-axis. So here's the home country. And we're going to put the quantity of computers on x and the quantity of shoes on the y-axis. And then down here we'll have the graph for foreign. So quantity of shoes, or computers, and quantity of shoes. This one's computers. So we got our two graphs set up. Now the question is, what would the relative shape of the two PPFs look like? Well, given the fact that computer production is capital intensive and home is capital abundant, it makes sense to think that the production possibilities frontier for home is going to be skewed relative to or towards computers. So it might look something like this. Right, compared to production in foreign, where you think that might be weighted or shifted or skewed more towards shoe production, right? Because shoe production is labor intensive and the foreign country is labor abundant. And so I've tried to draw these so that you could really see the distinction, right? And when you're working through examples, it really helps to just make the two PPFs very, very different from each other. So you go ahead and exaggerate that difference just so that it's a lot easier to see what's happening here. So those two assumptions show us that the PPFs are going to have a very, very different shape. Well, why is that important? Well, if you were to look at either of these two PPFs, and let's take some amount of computer production, well, what would we see? If you look at the PPF for home, you've got a fairly flat slope there, right? The PPF is relatively flat. Whereas if I had a similar level of computer production in foreign, somewhere like out here, that would be really, really steep, right? And remember, the relative price of the good on the x-axis is equal to the slope of the PPF. Right? And we saw this with the Ricardian model and with the specific factors model. Right? The slope of the PPF in equilibrium, at least, right, will be equal to the negative of the price of the good on the x-axis relative to the good on the y-axis, right? So in our case, that would be PC over PS, right? Price of computers over the price of shoes. Okay? So the question, of course, is, well, where is that equilibrium going to be? What will the equilibrium relative price of computers be? And this is where that last assumption that I just mentioned comes in handy, makes it easy for us. say, look, if preferences, household or consumer preferences are identical across the two countries, but they're faced with these different trade-offs on the production side, in equilibrium, we might expect something like this. So go ahead and just pick the equilibrium point for the home country first. Okay. Here's our indifference curve. And so what do we see here? Well, if we, that dotted line right there, that's the relative price line. Let's compare that to what we might expect to see for foreign. Well, we might expect to see that in the foreign country that given how, say, relatively difficult it is for them to produce computers, we might expect that the relative price of computers is going to be higher. So perhaps we end up with something like this. And if we draw our line, right, our price line, which again is reflecting the slope of both the PPF and the indifference curve in equilibrium, you can very clearly see that the relative autarky price for the foreign country is higher, right, the relative price of computers. So in equilibrium, right, when you combine the assumption that computer production is capital intensive, in the home country is capital abundant, and then add in homogeneous or identical preferences across home and foreign, this leads us to the prediction that we would expect the relative price of computers in the home country to be lower than for the foreign country. Okay? And why is that important? Well, remember, think back to both of our previous models, right? Specific factors and Ricardian. The country that has the lower relative price for a good has the comparative advantage in that good, because the relative price is also giving you the opportunity cost of producing that good. So ultimately, our assumptions add up to saying that the home country has its comparative advantage in producing computers. And so just as we showed with our previous models, if you open up to trade, what's going to have to be true? In order to get both countries to be willing to engage in trade, the world price is going to have to be somewhere in between the two autarky prices. So from the home country perspective, that's going to be seen as an increase in the relative price of computers. So if we add that world price in here and look for our tangency with the PPF, so maybe it'll be at a point like this. What would we see? Well, we would see an increase in the production of computers and a decrease in the production of shoes. Right? We have specialization in computer production. Of course, unlike the Ricardian model, this production isn't, the specialization is not complete. Right? We don't move in the home country to producing computers and only computers and completely give up shoe production. Right? We still continue to produce shoes. We just don't make as many of them as we did before opening up to trade. And if we look for our equilibrium in terms of consumption, right? So we produce here, but we consume up on, right, on that trade line. So in that case, we end up with, say, a point like here. And we can call that, and I'll actually call that for I'll call that D for the demand, right, or the consumption. And what do we see? Well, we see that we're producing up here, right, QC1, but we're only consuming at QCD in the home country. So what's that difference? Well, QC1 minus QCD, right? We're producing more than we're consuming of computers in the home country, so those are our exports of computers. Likewise, we're consuming QSD shoes, but only producing QS1, so that difference is our imports of shoes. Okay. And likewise, we could go in and do the same thing for the foreign country. We would notice that from their perspective, right, the relative price of computers is lower, so that price line is flatter than it is without trade. So their production would shift to a point like up here, and we'll put them on, say, a difference curve here. Okay? So what do we notice? Well, we notice that production shifts from QC 0, QS0 for them, up to a point like here, QS1 and QC1. Right, so their direction of specialization is the opposite from what we have for the home country. Right? Shoe production is labor intensive, and the foreign country is labor abundant. So what happens in general when we open up to trade? What do we notice? We notice that foreign, which is labor abundant, is going to increase its production of the labor intensive good and decrease its production of the capital intensive good. The home country, which is capital abundant, when it opens up to trade, will see an expansion of the capital intensive sector, right? An increase in production in computers and a decrease in production or a shrinking of the labor intensive sector, in this case shoes. Right? So this is the first basic insight that we have from the Heckscher-Ohlin model. Right? A country will specialize in producing the good that intensively uses the factor of production it possesses in abundance. Okay. Repeat that again because it's a kind of a mouthful and it can be quite a bit to try to absorb in one go. Right? A country will specialize in the production of the good that intensively uses the factor of production it possesses in abundance. In other words, the home country is capital abundant and computer production is capital intensive. So home is going to specialize in computer production, export computers, and then import shoes. Okay? That's the first basic insight from the Heckscher-Ohlin model. Now the next thing we want to do is take what we've shown here and ask, well, what are the implications then for the returns to our factors of production? What are the implications for the wage to rental rate? Right? Because in addition to predicting patterns of trade, patterns of specialization, we want to know what does this mean for the welfare of the different groups in our society here. And we'll pick that up in the next segment. Now that we've shown how to predict the patterns of specialization in trade based on the initial assumptions of which industry is capital intensive and which country is capital abundant, we'd like to take a next step and show, well, what does that mean for the returns to our two factors? labor and capital. And so we start, of course, by thinking about what happens to production. As we showed earlier, when we open up to trade, we go from producing at a point like A to a point like B. So we, in the home country, would see an increase in computer production and a decrease in shoe production. So what will that mean, right? That shift of production, well, that's going to entail a shift of resources across the sectors as well. So now we're going to go back to that other graph that I introduced at the beginning of the video when we were talking about factor intensity. And so we're going to write up on our y-axis. That's going to give us the relative prices of the two inputs, right? So the wage to rental rate ratio. On our x-axis, we're going to have the labor to capital ratio. Okay? And if you recall, what we said was the fact that shoe production is labor intensive, well, that means that at every wage to rental rate, shoe production employs a higher ratio of labor to capital compared to computers. And you can see that visually by the fact that the relative demand for labor, or the relative usage of labor in the shoe sector, is shifted over to the right compared to that for computers. Okay? Now, in addition to that, we've also got our relative supply. Okay? This is a supply and demand model. Okay? And so our relative supply of labor to capital is fixed. And we're going to take that as being fixed, and that L bar over K bar. Okay? Now, what we need to add in here is our economy-wide relative demand for labor, right? So you think of each of these curves as representing the sector or industry relative demand for labor, right? So this is the relative demand for labor in computers. This curve is the relative demand curve for labor in the shoe sector. Well, how do you get the economy-wide or the aggregate relative demand curve? Well, that's going to be a weighted average of these two relative demands. How can we see that? Well, we start with our equilibrium, a recognition that in equilibrium, the relative supply of labor has to be equal to the relative demand for labor, right? So the L bar, K bar represent the supply side, and the L bar, the L over K without the bars on them, those are going to represent the demand side, relative demand for labor. Well, you can take that L and split it up into LC, right, which is the amount of labor employed in computers, plus LS. Right? That's just an accounting identity. Right? We've taken L and said, well, what is L? L is the total labor used. Well, that's equal to the amount of labor employed in computers plus the amount used in shoes. Right? And so if you look at this, well, what can we do here? I'm saying this is LC over K. You could split that up into its two pieces, plus LS over K. So if we split those up, we have that. Now, what can we do with what we have here? How can we show that the overall labor demand is kind of an average, right, a weighted average of these two individual labor demands? Well, when you look over here, what do we have? We have LC over KC, right? That's the relative demand for labor in computers. So we'd like this first term to have that same ratio in it. So how would we get that? Well, to get that, you can take that LC over K and divide by Kc, right? So now we have Lc over Kc, but of course the fact that we've divided by Kc, if we want to maintain that, we also will multiply it by Kc, right? So in essence, when you multiply and divide by the same variable, you're just multiplying by 1, right? So mathematically legitimate operation. We've not changed this equation, right? And then the second part of it was the Ls over K. Well, I want to do the same thing, right? We want to divide by Ks. And then we'll multiply by Ks. So that's really all we had to do here, is we basically did things in 2 steps. First, recognize that total demand for labor is equal to the demand for labor, the amount of labor used in each sector. And then recognize that we want to be able to write this equation in terms of the relative demand or relative employment of labor within each sector. And now we can just rearrange these terms. And so if you think about what we actually have here is Lc over Kc, which is the relative demand for labor in computers, times Kc over K, which is what? Well, that's the share of capital that's employed in computers, plus Ls over Ks, which is the relative demand for labor in shoes, times Ks over K, which is the share of capital that's employed in the shoe sector, right? So when I say that the aggregate relative demand for labor is a weighted average of the 2 industry relative demand curves, those weights are given by Kc over K and Ks over K. And of course, one thing you can see is that what is Ks? Well, Ks is just equal to 1 minus Kc. Right, so if I increase Kc, if I put more weight into the computer sector, then I'm putting less weight, and Ks will go down. I'm putting less weight in the shoe sector. So if we can go ahead and say draw our economy-wide relative demand curve. And let's say that's just L over K. 0, that's be our initial relative demand for labor. And of course, simple supply and demand, a little more complicated than the basic supply and demand graphs that you see in principles, but basic concepts are the same, right? It really is just at its heart a supply and demand graph. Just we're looking at relative supplies, right? Relative quantities and relative prices. So the intersection of the relative supply curve with our relative demand curve gives us the equilibrium wage to rental rate. Right? So this is so far before we've even opened up to trade. This would be our autarky equilibrium, right? Our no trade equilibrium. Well, what happens when we open up to trade? We'll go back to our PPF. What we saw here was that our production shifted from A to B. Increase in computer production, decrease in shoe production. So what does that mean? Well, in terms of our weights, in order to increase computer production, we're going to have to pull both labor and capital out of shoes and into computers in order to expand computer production. So in other words, this Kc over K, right, the share of capital that's employed in computers is going to increase. At the same time, Ks over K is going to decrease because we're taking labor and taking capital out of shoe production in order to put them into computer production. So what does that mean? Well, that means that our aggregate economy-wide relative demand curve, we're going to put more weight on the computer sector. So that means that the aggregate curve is going to shift down. Right? It's going to be putting more weight, so it's going to be closer to the relative labor demand curve for the computer sector. So what does that mean in the end? Well, our wage to rental rate will go down. Now, up to this point, we've said simply that the wage to rental rate, that ratio goes down, but we want to know, well, in absolute terms, not just relative terms, but in absolute terms, what happens to these two different prices, right? The wage rate and the rental rate, the returns to these two factors. Now, in order to think about that, we can make use of conceptually something we talked about in the specific factors when we discuss specific factors model. And we're going to go back and think about the marginal productivity of capital and the marginal productivity of labor within each sector. Okay? And again, this graph here is going to come in and be very useful for us. So now that the wage to rental rate has gone down, what is that going to mean for relative employment of labor within each sector? Okay, and this is the key step in terms of understanding what happens to the wage and rental rate in absolute terms, not just the wage to rental rate ratio. Now, let's focus on the computer sector first. Initially, when we had W over R0, if you take that wage to rental rate, you could take that and see where it intersects the relative demand curve for labor for computers. And that happens at this point here. Well, that tells us that LCKC0, which is the relative demand or the relative employment of labor in computers, is initially here. What happens when the wage to rental rate falls? Well, when that falls, labor is becoming relatively cheaper, right? Relative to what? Well, relative to capital, right? We're lowering the price of labor relative to capital. So logically, producers are going to shift their input mix away from labor, or towards labor and away from capital, right? If labor is getting cheaper, we want to use a higher ratio of labor to capital, and we're going to see that right here. Right? The labor to capital ratio in the computer sector goes up from 0 to 1. Right? We see that increase. Same thing, we could see the same thing for the shoe sector. Right? They're going to go from here down to here. Right? So they're going to also increase their labor to capital ratio. Okay? So that's one important insight here, is that in order to maintain equilibrium between relative supply and demand for factors, right? When we open up to trade, because the relative price of computers goes up, we shift more production into computers away from shoes. But in order to get that to happen, in order to keep all of our factors of production employed, it has to be that the wage to rental rate will drop in order to get producers within both sectors to use a higher ratio of labor to capital. Right? So within both sectors, the ratio of labor to capital employed goes up as the wage to rental rate falls. And this is what allows us to continue to fully employ labor and capital. Otherwise, it's not possible, right? So think about it this way. As I'm releasing labor and capital from the shoe sector, I need to get all those workers and all of that capital employed in the computer sector. Well, how can that be? So I think here, just if we make up a quick example, this might help to see why this all has to work this way. So let's say that initially, in order to produce a unit of computers, I'm using 1 worker and 4 units of capital, right? And then let's say in the shoe sector, I'm using 2 and 2. Okay. All right, this is to make one unit. So if I want to make 1 more unit of computers, what do I need? I need to take 4 units of capital out of shoes. Right? So that means I've got to take 4, right? Well, if I take 4 pieces of units of capital out of shoe production, that means I'm also no longer using those 4 workers that were going along with that capital to make those shoes, right? So, okay, what's going on here? So I take those 4 units of capital and I put them from shoes into computer production, but the computer industry only wants to use 1 of those 4 workers. I've now got 3 workers who are unemployed, right? Because we're shifting resources from the labor to the capital-intensive industry. So what would that do? Think about it. You have all these workers who, again, the workers are homogeneous and they're equally able to work in either sector, but these workers are no longer employed. So what's going to happen? You have these unemployed workers. You can imagine that they'll start, right? You've got this excess supply of labor. Well, that'll start bidding the wage down. And as their search for work bids the wage rate down, that's what's going to cause ultimately employers, producers in computers and the shoe sector to start hiring more workers, right, to reabsorb those freed up resources. Right? So a little numerical example like that helps us to see what's going on and why this all has to be the case. Well, so what does all of this mean then for our returns to capital and labor? Well, remember, the marginal product of capital is equal to what? You're going to be at least a function of the labor to capital ratio. And likewise, right, the marginal product of labor will be a function of the capital to labor ratio, right, at the other way around, just because, right, the marginal product of capital increases as the labor to capital ratio increases, whereas the reverse is going to be true for labor, right? The marginal product of labor will increase as the capital to labor ratio increases. This is nothing new. We've already discussed this in terms of both we discussed this in terms of specific factors, right? Couldn't discuss that in terms of the Ricardian model because there was only one factor of production. Right? So this is conceptually, this isn't new. And again, I go back to what I said earlier in a previous video, that one thing it helps is sometimes if you recognize we're using the same core concepts, basic techniques as we move from one model to the next, right? And you can see how some of these basic ideas can be used when we're working through each of these different models. So ultimately, what does this mean for us? Well, in terms of how is this useful? If we're looking at the real returns, well, what is the rental rate on capital? Well, the rental rate on capital is equal to and I'll focus on the computer sector first, right? The price of computers times the marginal product of capital in computers. It's also has to be equal in equilibrium, right? Because we're using capital in both sectors, equal to the price of shoes times the marginal product of capital in shoes. Right? And we can write both of these in real terms by dividing through by the prices. Because as stated before, what we care about the real rental rate and the real wage, right? We care about the purchasing power of the wage and of the rental rate. And likewise, we can also write, right, that the wage in real terms would be equal to the marginal product of labor in computers, and the wage in real terms in terms of the price of shoes equal to the marginal product of labor in shoes. Well, what's happening to these real prices? The key is what's happening to the marginal products. All right, so think about it, because the price of computers, when we open up the trade, the price of computers is going up, but the price of shoes is going down. They're moving in opposite directions. So even if nominally the rental rate's going up, it doesn't guarantee, at least what we said so far, that the RK, right, the rental rate to ratio over divided by the price of computers is going up, right? They're both moving in the same direction. But focus on the marginal product of capital. And what did we see happening? As the wage to rental rate falls, within each industry, the ratio of labor to capital employed goes up, which means that the marginal product of capital will go up. That means the real return to capital, the rental rate, divided by the prices of the goods will go up. The flip side of that, right, as L over K is going up, that's saying that K over L is going down, which means that the marginal productivity of labor is falling. And as the marginal productivity of labor falls, that means that the real wage rate, in terms of either good, is also falling. So not only is the wage to rental rate going down, what we're actually seeing is that the wage rate in real terms is falling, and the rental rate in real terms is increasing. Right? And this is what gives us that Stolper-Samuelson theorem. All right, we get our very, very important theorem here. And this is that, again, this is kind of like the Heckscher-Ohlin theorem stated earlier. This is a bit of a mouthful, and it can be much to take in at once. So I'll kind of give you the general theorem and then step back and just state it again in the context of this example. So when we open up to trade, what do we see? We see that the factor of production, which a country possesses in abundance, the real return to that factor will increase, and the real return to the other factor will decrease. Okay? In other words, the way we set up this example was the home country is capital abundant. So when we open up to trade, capital, right, the abundant factor, sees its return, the rental rate, increase in real terms. Labor, which is the relatively scarce factor, sees its return, right, the real wage rate, decrease. Okay? Now, of course, everything we say for the home country, the reverse holds true for the trading partner for the foreign country. So when we open up to trade in this example, the home country sees the relative price of computers fall, or go up rather. So we increase computer production, decrease shoe production. That causes the relative demand for labor economy-wide to shift down, causes the wage to rental rate to fall, increases the labor to capital ratio employed within each sector, and then ultimately that leads to a fall in the wage rate in real terms and an increase in the wage rate, in the rental rate in real terms. The opposite patterns will happen for foreign, right? When we open up the trade, foreign is going to decrease computer production and increase shoe production, causing relative demand for labor to increase in the foreign country, and then ultimately the wage rate to go up in real terms and the rental rate to fall in real terms. Everything that happens in this model goes back to the change in relative prices when we open up to trade. Right? Everything falls down from the response to seeing those change in relative prices. I mean, that's the key in economics is one of the keys is recognizing that prices are signals and that economic agents respond to changes in those prices. To help reinforce everything, next we're going to do a numerical example showing the changes in the wage to rental rate in real terms. Okay, so just as we did for the specific factors model, I'm going to work on a numerical example to help reinforce these ideas of what's happening to the real returns to our factors of production. One major difference is here with Heckscher-Ohlin, we only have two factors of production. We have two industries, two factors of production. They're both freely mobile. So we only have to solve for two prices, right? The change in the wage rate and the change in the rental rate. And so we can do that with a two-equation model. We couldn't do that with specific factors. We had three input prices to solve for. So what we did was we just assumed a change in the wage rate and then solved for the changes in the rental rate for capital and for land. So similar conceptually, but some differences given that we're working with a different number of factors compared to what we did for specific factors model. But we start from the same starting point here. And we recognize that the rental rate for capital times the amount of capital, actually I'll just use C's here, the subscript, because there's only one rental rate. So RCKC, what is that? So that's total payments to capital in the computer sector. Well, remember, that's equal to revenue in computers minus wages paid to workers employed in computers, right? So similar to what we did in the previous, looking at the previous model with our numerical example. And we took a few steps to show that if you divide through then by KC, right, and what do we want to do? Well, we want to convert this into the percent changes, right? And so we said, well, you take this as the change in the rental rate in computers is equal to the change in the price times that quantity minus change, right? We did changes for all of our dollar values, right, our prices, and divided that through by K. And as a next step, we said, well, what we want to do is we want to convert these into percentage changes, right? So how do you do that? Well, you got to divide through by KC that we had. So change in R times R, right, in rental rate in computers. So RCKC. So what's RCKC? Total payments to capital in the computer sector. And now what are we going to have to do? So we divided through on both sides, so that was fine. Well, we want to convert this into a percentage change as well. So we'd like to divide through by the price in computers, but then we have to multiply. Right? So divide and multiply by the price of computers, and that turns that first term into the percentage change in the price of computers times PCQC minus percent change in the wage times WLC, because likewise we're going to divide by W and multiply by W. Dividing by W here turns this into the percentage change in the wage, and multiplying by W makes this WLC all over RCKC. Well, same thing, you can work through the same steps and you'd have same expression or similar expression for the shoe sector. Right, the percent change in the price of shoes times revenue in the shoe sector minus the percent change in the wage rate times wages paid to labor in the shoe sector, all divided by RSKS. Now, of course, what you should recognize is that these two rental rates, right, they're the same. Right? So you can get rid of these subscripts here. I had RSKS, but you don't really need them. Right? In equilibrium, the rental rate's got to be the same across the two sectors, just as the wage rate has to be the same across the two sectors, because our factors are freely mobile between shoe and capital production, right, across the two sectors. So what does that mean? Well, now we've got two equations, and we've got, right, the change in the rental rate and the change in the wage rate to solve for. Right? And this all comes from, right, our other two prices, the goods prices, those are changing as a result of opening up the trade, right? Those changes are exogenous to this little model. So here's our setup, similar to what we saw before. We have total revenue in computers is 100. Total revenue, out of that 100, $50 is paid to labor, 50 to capital. Keep things easy. Total revenue in the shoe sector is also 100, but here, $60 is paid out in wages and $40 in terms is paid out in rentals to capital. To stay consistent with the example that we worked through graphically, we'll have the price of computers go up by 10%. And just as we did when thinking about, right, the specific factors model, in reality, we say, well, we expect that the price of shoes is falling, but it's just simpler in terms of working through the problem just to keep keep that price just at no change, right? So the relative price of computers is going up in this example because the price of computers is going up while the price of shoes is staying constant. We could also have the price of shoes falling. It won't change any of the qualitatively any of the predictions that we get here. Everything will still hold. It's just a lot more complicated to work through. So if we can start plugging in here. Right, the percent change in the rental rate is equal to a 10% increase in the price of computers times 100 minus the percent change in the wage times 50 all over 50. And the percent change in the rental rate from our second equation, which is equal to the percent change in the price of shoes, which was 0, times 100 minus percent change in W times 60 all over 40. So what does that simplify down to? It simplifies down to, so 10% of 100 is 10, so that's 1/5, or 0.2, minus the 50 over 50 cancel, and we just have the percent change in W. 0% times 100 is 0, so the first term pops to 0, minus percent change in the wage times 60 over 40, which is 1.5. That's equal to a minus 1.5% change in the wage. Again, since these two rental rates are equal to each other, we can just set equation 1 equal to equation 2. And what does that give us? Well, that says then that the minus 1.5% change in the wage is equal to 0.2 minus percent change in the wage. Right? And I'll bring the percent changes in the wage over to the right-hand side to make it positive. And what does that give us? It says, and then so bring the 0.2 over to the other side, minus 0.2 equals 0.5% change in the wage, right? Multiply by 2, both sides by 2 to get rid of the 0.5, and you get that the percent change in the wage is minus 0.4, right? Or in other words, minus 40%. So what do we go to as a next step? Well, we can now take that minus 40% and plug that into either one of our equations. So if I take that and plug it into 1, what does that tell us? Well, then the percent change in R is equal to 0.2 minus 0.4, or minus 0.6, which is minus 6, or sorry, minus a minus, which becomes a plus, right? 60%, right? Because we're plugging in a minus 0.4 into so the two negatives turn into a positive. Or I could plug it into equation 2 instead. Right? Plug that into equation 2, and we see the percent change in R is equal to negative 1.5 times the negative 0.4, which once again gives us plus 0.6 or plus 60%. Right? If you did everything correctly, you should get the same answer by plugging it into either equation. So what are we seeing here? We're seeing that the wage rate fell, right? And it fell by quite a bit, it fell by 40%, and the rental rate increased by 60%. Let's compare those changes to the changes in our prices. Okay? So when you look at this, the percent change in the wage rate, which was minus 40%, is less than the fall in the percentage change, right, fall in the price of shoes, which was 0, which is less than the change in the price of computers, which was plus 10%. And then lastly here, the percentage change in the rental rate, which was plus 60%. So when you put all this together, what do we see? Right? We say, look, we started with a fairly modest increase in the price of computers. Right? Price of computers only went up by 10%, and that gives us these outsized changes to the rental rate and the wage. Right? The price of computers went up only by 10%, but in this example, that causes the rental rate to go up by 60% and the wage rate to fall by 40%. This is what we call the factor price magnification effect. And this is a feature, prediction of the Heckscher-Ohlin model. Why is this important? Because this tells us, look, you only need relatively small price changes as a result of opening up to trade to generate relatively large changes in factor prices. And of course, what most people are concerned with, if you think about the media, if you think about politicians, everyone focuses on, of course, the wage rate. Right? Everyone's always concerned with what's happening to wages. And in particular, you can rethink the setup of this entire model so that instead of talking about labor and capital, we could have been talking about skilled workers versus less skilled workers. Right? And seeing how, if you think that the United States is skill abundant, which by pretty much any metric we are, then when we open up to trade, the wages for skilled workers should go up, whereas the wages for less skilled workers should go down, which is something that we've been debating and discussing as a society. You think about any election, presidential elections, Senate races, you think about how much these topics come up. Well, this is saying that, the stagnation of real wages for less skilled workers that we saw for a couple of decades, that might actually be possibly caused by rising imports and falling prices for those goods, even though we're only observing relatively modest decreases in the prices of the goods that those workers are producing. Okay? So empirically, this factor price magnification effect has the potential to really to say that, hey, trade can play a big role here. And we'll discuss the empirical evidence surrounding a lot of these predictions of the Heckscher-Ohlin model in class.